In this video, we'll take a look at why NASA is giving up on the James Webb Space Telescope. Webb begins its science mission after years of extensive development and testing. A successful launch and deployment, a carefully managed cooldown, precise mirror alignment, and instrument calibration. And finally, the stunning release of its first full-color images. The publication of Webb's first images and spectra marks the start of Webb's science operations, in which astronomers from all over the world will be able to observe anything from objects in our solar system to the early universe using Webb's 4 instruments. The James Webb Space Telescope is the world's leading observatory for space science. Webb will investigate mysteries in our solar system, as well as distant worlds orbiting other stars, and will investigate the mysterious structures and origins of our universe, and our place in it. Webb is an international program led by NASA in collaboration with the European Space Agency and the Canadian Space Agency. On December 25, 2021, the James Webb Space Telescope was launched. A meteorite struck and clung to one of this object's telescope mirrors while in space. NASA scientists conducted some investigations to determine how severe the damage could have been, and they discovered that there was no serious damage. According to experts, everything is fine and there is nothing to worry about. According to scientists, Webb has enough fuel to last 20 years. Launch controllers were concerned about the weather for the second lunar mission after being struck by lightning. Before the astronauts were shut inside, the crew reported rain on the Yankee Clipper's windows. Controllers started the countdown after assessing the weather. How wrong they were, and nature wasted no time in making them realize it. At 11:22 a.m., the Saturn V rocket carrying 3 astronauts to the moon lifted off. After 36 seconds, Pete Conrad noticed a brilliant flash of light, and the capsule's master alarm shrieked. The instrument panel on the command module displayed electrical warnings. The machine, NASA's largest optical telescope to date, was named after NASA Administrator James E. Webb, who held the position from 1961 to 1968. However, the decision may land the American Space Agency in hot water. Between 1950 and 1952, hundreds of US government employees were fired on suspicion of being homosexual, a phenomenon known as the Lavender Scare. A recent Scientific American opinion urged NASA to rename the telescope, claiming that Webb was involved in or knew about the dismissal of queer people as a person in a position of administrative power. There is no record of him choosing to speak out for the humanity of those who are being persecuted, the author wrote. Aside from the Lavender Scare allegations, Webb's legacy is marred by a 1967 ground test incident in which 3 Apollo 1 astronauts died. After conducting an investigation and discovering no evidence at this time that warrants changing the name, NASA announced that it would keep the JWST name. Since its perfect deployment earlier this year at a distance of 1.5 kilometers from Earth, the James Webb Space Telescope has faithfully transmitted incredible images of space. But nothing, not even a $10 billion telescope, is perfect. Because of the JWST's surveillance mechanisms has malfunctioned, mission engineers are already working on a solution. According to NASA, the MRS mechanism experienced increased friction while being set up for scientific observation on August 24th. The space agency has called a commission meeting to determine the best way to solve the problem. NASA has temporarily suspended surveillance while the commission analyzes the problem and develops solutions. MRS is a component of a mid-infrared instrument that sees light in the mid-infrared region of the spectrum using a camera and a spectrograph. MIRI has 4 observation modes: visualization, coronagraphic imaging, low and medium resolution spectroscopy, and spectroscopy. According to NASA, the failure is caused by a mechanism that allows switching between short, medium, and long wave observation modes. The issue was discovered to be the gear that switched between these modes. As a result, MIRI observations have been halted. James Webb is operating normally and carrying out its scientific mission. The other 3 MIRI observation modes, visualization, low-resolution spectroscopy, and coronagraphy, are operational and available for scientific observations. According to the space agency, James Webb recently astounded us with images of Mars's neighboring planets and Neptune's rings. However, the telescope is now preparing to photograph the moment the DART spacecraft collides with the Dimorphos asteroid. Because Webb is expected to operate for another 20 years or more, we should expect more failures in the future. But we hope that the observatory will be able to overcome several technical issues during its scientific space mission. The James Webb Space Telescope's MIRI instrument has finally resumed operations. The issue was discovered to be in the MRS mechanism. NASA describes an instrument malfunction that caused increased friction when establishing scientific observations. As a result, the Webb team was forced to turn off the camera while they investigated the issue and worked on a solution. James Webb is too far away from Earth at the L2 Lagrange point to send a team for physical repairs. Engineers were forced to look for a solution remotely. Under certain conditions, the team concluded that the problem is caused by an increase in contact forces between the components of the central wheel bearing assembly. Based on this, the team devised a strategy to employ the affected mechanism in scientific operations. NASA explains. The team's decision proved to be beneficial. On November 2nd, engineers performed a test to determine the friction of the mechanism's wheels, which in the end does not interfere with work. As a result, on November 12th, James Webb will resume scientific observations using MIRI. The MIRI camera on board the Space Observatory is back in action just in time to take advantage of a once-in-a-lifetime opportunity to observe Saturn's polar regions before they become inaccessible for the next 20 years. This weekend, we'll see the first observations. James Webb was able to capture some of the most detailed images of the universe to date in the highest resolution. But not everything went as planned. Although the telescope was able to reach orbit and fully deploy without incident, it was hit by a meteorite earlier this year, which damaged one of the main segments of its mirror. Thankfully, the damage was minor. When a damaged Apollo 13 and its crew were on their way back to Earth, Mission Control Director Gene Kranz famously told the assembled NASA team that failure is not an option. Actually, the actor who played Kranz in the film Apollo 13 said those words. But Kranz and his team lived that phrase, with a drive that became a reality. With a few tragic exceptions, the kind of hard-driving confidence appears to be built into NASA's DNA, and it has served the agency well in its numerous high-precision and high-drama ventures. Risk reduction has been a long, painful, and expensive process. The telescope, which will see further back in time to the origins of the universe than any other telescope, began development in 1997 and was originally scheduled to launch in 2007. However, the JWST's complexity as well as its uniqueness and some well-documented human and corporate errors have resulted in numerous scheduling delays and cost overruns. The telescope was initially priced at $500 million, but will eventually cost in the $10 billion range. Many of the JWST's components had to be created from scratch, including the main mirror's 21-foot diameter, which is made up of 18 hexagonal segments made of gold-plated beryllium. A sun shield and cryo cooler keep JWST instruments just a few degrees above absolute zero, allowing for the infrared observing for which it was designed, and thousands of micro shutters, each thinner than the width of a human hair, that open and close to allow light from targeted objects to reach the telescope's sensors. Technology to unfold delicate objects the size of the main mirror and the sun shield, which is roughly the size of a tennis court, will also be brand new. All of this must fit into the fairing of an Ariane 5 rocket, which will launch from the European spaceport in French Guiana. In August, the JWST will be shipped to Kourou via the Panama Canal. Those 344 single-point failures occur from the beginning of the spacecraft's journey to the Sun-Earth L2 Lagrange point in space, some 930,000 miles from Earth, to the final robotic mirror unfurling when it arrives. While NASA has gotten very good at robotics, as evidenced by its Mars rovers and other missions, the JWST deployment is in a robotic class of its own. Moreover, unlike the Grand Observatory, it will augment and eventually replace the Hubble Space Telescope. The JWST will be too far into space for astronauts to arrive and repair it, as Hubble was 5 times. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.